Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. We are from Cobalt Navitas Corporation, and today we will present about the proposal of architectural application of 316L stainless steel. So a little bit about our company. Our company has been founded since 2016 and has been striving for the use of quality and efficient technology in various fields of engineering. Our company based in Cyberjaya, and the idea of developing quality technology and material for engineering project lays off our company's foundation. We've involved in various fields of engineering, be it mechanical, civil, electrical, even chemical engineering projects. We also constantly maintaining a good rapport with our clients from past projects, and also we from time to time, we stay up to date with the latest technology and developments in order for us to meet the requirements for our upcoming clients in the future. So this is our dedicated personnel of our company, starting with myself, Farrez Noor, together with Sharief Ghazali, Mohamad, Qhaireel, Mikhail, Mohamad, Razeef, Mohamad Afdhal, Abdullah, and also Mohamad Hafizam, Rahman. We have three objectives today. The first one is to provide a better understanding on the properties of the selected 316L stainless steel grade raw material. We also want to propose a better and enhanced rendition of the selected material, and we also want to present technical findings obtained from our company in order for us to convince the client about the proposal we made today. So the main idea for this project is actually the developers and the design architects for KLCC Tower. They want to build the encased stainless steel extrusion part and pinnacle tops for each tower. So after they've gone through some research, their interests have been dragged into using the 316L stainless steel for the construction. So our company is stepping into the game in order for us to provide the technical findings and also the justification in related to 316L stainless steel in order for us to convince the developer that this is the great material and this is the material that should be used in this project.
So, what exactly is the 316L stainless steel? I'm gonna get you through it, but first, let me explain to you the 316 grade stainless steel. The stainless steel grade 316 is an alloy of steel with 11% of chromium and more than 50% of iron. It is a composition of elements such as carbon, chromium, nickel, silicon, and phosphorus. And if we add some metals like molybdenum or titanium into the composition, it can modify and increase its mechanical and physical properties. The 316 grade stainless steel is the standard molybdenum bearing grade. It is highly strained, corrosion resistant, and rust resistant, especially in highly chloride environments, and it only requires the minimum maintenance. It has excellent forming and welding characteristics. It is readily break or roll formed into a variety of parts for industrial, architectural, and even transportation purposes. There is the low carbon version of it, stainless steel grade 316L, similar to the normal 316 but even better in some ways. It is immune to sensitization, which is the forming of the grain boundary carbide precipitation. The chromium carbides tend to precipitate at the grain boundaries of any austenitic stainless steel in the 400 to 700 degrees Celsius temperature range, which usually occurs during welding or hot forming process. Any exposure or thermal excursion into this temperature range could potentially sensitize the steel, which is why the 316L grade is more extensively used in heavy gauge welded components. One of the alternatives to enhance the mechanical properties of the stainless steel or any other metal is through the cold rolling process. It is used particularly to increase the tensile properties of the metal. It is a process of deformation, a sheet of metal rolling between two rolls at room temperature. A reduction in thickness results from the compressive stresses exerted by the rolls will harden the metal. The strength of the metal will be increased as well, while the ductility will be decreased. We will further discuss about the differences between a normal and a cold roll metal, which in this case for the 316L grade stainless steel.
To know the difference between these two specimens, two tensile tests has been performed towards original and cold rolled specimen. As you can see, the figure shows the graph of stress over strain curve of original stainless steel 2.0 mm that have been constructed until the maximum load applied, which is 10.38 kN before the specimens get fractured. For the next figure, the graph of stress over strain curve of cold rolled stainless steel 1.0 mm that have been constructed until the maximum applied load, which is 8.02 kN before it turns fractured. For the next slide, the results obtained from the graph has been extracted into the table to see the comparison between these two specimens. For ultimate tensile strength, the cold rolled stainless steel recorded 642 MPa, while original stainless steel recorded 415 MPa. As for yield strength, the cold rolled stainless steel recorded 975 MPa, while original stainless steel is 280 MPa. After doing calculation, the modulus of elasticity recorded for cold rolled stainless steel is 135.7 GPa, while original stainless steel is 70.8 GPa. As for ductility, the cold roll recorded 1.95%, while original recorded 22.13%.
Next part is relationship between microstructure and mechanical properties. So number one, the size of untransformed austenite in cold roll samples decreased when cold reduction increased from 10% to 40%. The decreased size of untransformed austenite was attributed to the increasing boundary density of dislocations, mechanical twins, and strain-induced martensite that formed during the cold rolling process. Next, the grain refinement of untransformed austenite faced an increasing content of strain-induced martensite resulted in an increased yield or tensile strength and decreased ductility of 316L austenitic stainless steel under the influence of increasing the cold rolling reduction. The last but not least is the cold roll 316L austenitic stainless steel with high yield strength and reasonable elongations had a good strain hardening ability and exhibited a 3-stage strain hardening behavior.
To further improve the overall strength, a temperature treatment, which is the cold rolling process, can be done to enhance the resistance to residual stress, and it can be up to 20% stronger than typical stainless steel. This is made perfect for the biggest and the toughest of project. Using cold roll steel also look better in outcome finishing as it results in smoother surface. It is preferred technique to produce aesthetically pleasant modern look. By comparing four-board sample of the original and the cold roll 316L grade stainless steel, the obvious difference between them is the size of grain. As the metal is shaped at the lower temperature, the steel hardness, resistance against tension breaking, and resistance against deformation are all increased due to the hardening. This gives a resulting partial martensite transformation, which is meant by a reducing of the austenite fraction in the microstructure. The 316L grade stainless steel is good, but undergoing the cool rolling process make it even better.